Hey, it's Amasa from Lighthouse Geospatial, where we give you practical how-to tips on GIS techniques and workflows to improve your knowledge and efficiency. In this video, I show you how the real world is represented in GIS, see how real-world relationships are preserved, and understand how to model geographic data using the vector and raster models. Let's get started. The real world is made up of people, places, and activities, some of which have fixed boundaries and others unclear boundaries. Time is also important, as activities may happen in sequence and there may be dependencies within the sequence. And more than likely, there is missing information within all of this. So, to represent this complexity in GIS, we have to make things as simple as possible. This is done by coding spatial data in a digital format that the computer and GIS can understand. So, now that we've understood how we translate our data into a nice computer-friendly format, we want to make sure that we can model the relationships that exist in the real world within our data. These relationships are called topology, and they refer to the spatial relationships that exist within features in the real world, like connectedness, adjacency, and proximity. Topology allows us to do two key things. One, manipulate our data within GIS so we can twist it, bend it, squash it, and trust that all the data stays interconnected. And two, we can use these spatial relationships that exist within the data as inputs to data management routines or analysis workflows. This is what enables GIS to model the real-world behaviors on spatial data within a computer and make sure that we can get all the questions that we ask of the data. Now that we understand how the real world is represented and also seeing how these real-world relationships are preserved, let's have a look at how this geographic data is modeled in GIS, starting with the vector model. Simply put, vectors are made up of a series of XY coordinates that pinpoint locations of features on the Earth. There are three types of vector data. Points that are used to represent discrete features like building locations. These are expressed as a single XY or latitude-longitude value in the real world. Lines are used to represent linear features like rivers. These are a series of XY points connected at vertices to make up the line feature. And polygons, which are used to represent area features like parcel boundaries. These are a closed loop of linear features. Rasters are made up of regularly spaced grid cells or pixels. Each pixel is assigned a value that represents the feature underneath it. Rasters are generally used to represent features that do not have well-defined boundaries, like temperature, snowfall, pollution, and features that vary across the surface, like elevation.